Section 2.6, Extreme Values of Functions. Extreme value is just the highest or lowest point of a function. So I like to think of kind of like a camel's back. Look something like that. It has extreme values at all the humps. So the top of the hump and the bottom of the hump, right there, there, and at the top of that. So those are all extreme values. They can be maximums or minimums. So the first thing we're going to talk about is quadratic functions. So the general form of a quadratic is just ax squared plus bx plus c. If it's in general form, you can find the extreme value at the vertex, which would be negative b over 2a, and f of negative b over 2a, just the output when you plug in negative b over 2a. If a is positive, the parabola would be opening upward, so the extreme value would be a minimum. The vertex would be the minimum. And if a was negative, it would be opening downward, so the extreme value would be a maximum. There's also standard form for a quadratic, which is a x minus h squared plus k, where the vertex is hk. And then same thing, if a is greater than 0, it will be a minimum. If a is less than 0, it will be a maximum for the same reason. So we're going to sketch the graph by completing the square, because that way we can look at it as the basic parabola with shifts and transformations. So to complete the square, you separate c away. Then you need to factor out whatever's in front of the x squared. So when you factor out the 2, this becomes 6x. Keep your 23 way over here separate. Now we're going to complete the square inside the parentheses, so b over 2 squared. So 6 over 2 squared, so that would be negative 3 squared is 9. So we're going to add 9 inside the parentheses, and we're going to add 9 we actually need to subtract 9 to keep it balanced, because they're on the same side of the equation. So if we add 9, we need to subtract it. But since we're adding 9 in parentheses with a 2 outside, you have to do the exact same thing. We need to do 9 in parentheses with a 2 outside, because this would really be 18, so we need to really subtract 18 if you were to think about it that way. So now we can factor in the parentheses. That is a perfect square. X multiply to be 9, add to be negative 6, be x minus 3, negative 3 times negative 3. So squared, with the 2 out front. And this would be 23 minus 18, which is 5. So our function is f of x equals 2x minus 3 squared plus 5, which means it's a parabola shifted up 5 and right 3. So the vertex is going to be right 3 and up 5. And then since a is 2, it's going to be vertically stretched by 2. So it's going to come up here. Like that. So here's another quadratic. Let's first convert to standard form, just like we did by completing the square. So let's do two things at once. Let's factor out the 5. And separate the 49. So now when we do b over 2 squared again, 6 over 2 is 3, 3 squared is 9, so we're going to add 9 in parentheses with a 5 outside. So add 9 in parentheses with a 5 outside. Subtract it. So factor inside the parentheses x minus 3 squared again. We have a 5 outside. 5 times 9 is 45. 49 minus 45 is 4. So there it is in standard form. So if we are going to sketch the graph, it shifts right 3 and up 4. There's our vertex. Now there's a 5, so it's vertically stretched by a factor of 5. So it's going to be really steep. So the minimum value would be here at the vertex, because A was positive, it's opening up. So the minimum value is the vertex, which is 3, 4 is the vertex. So the actual minimum value is 4. And you could write the minimum value is f of 3 equals 4. Almost the same equation here. Now we have negative x squared plus x plus 2. So again, let's factor out the thing in front of the x squared. And separate the 2. So now it's b over 2 squared. So it's 1 over 2 is 1/2. 1/2 squared is 1/4. So we're adding 1/4, so we need to subtract 1/4. There's a negative outside, so we need another negative outside. Factor the parentheses, so that would become x minus 1/2 squared. It's always going to be b over 2, because then when you square it, you get 1/4, and if you add it together, you get b. Plus 2 plus 1/4, so let's write that as 9/4. So if you sketch the graph, this is shifted to the right 1/2 and up 9/4, or 2 1/4. So our vertex is right about there. And it is negative, which means it's reflected over the axis, so it's opening down. Like that. Find the maximum value. Well, that's going to happen at the vertex. The vertex is 1/2, 9/4. So you can say the maximum value is f of 1/2, which is 9/4. For these next examples, let's use the shortcut, the b over 2, negative b over 2a. So in this example, b is 4, so that would be negative 4 over 2 times a is 1, so 2. So that's negative 2. So our extreme value is going to be f of negative 2, which is going to be negative 2 squared plus 4 times negative 2. Simplify that. That becomes 4 minus 8, which is negative 4. So f of negative 2 equals negative 4 is our extreme value. Since a is positive, that means it's going to be a minimum. For example B, we'll do the same idea. Negative b over 2a. So that's negative 4 over 2 times negative 2. Simplify that, you get 1. Now let's find our extreme value, f of 1. So that's negative 2 times 1. Plus 4 times 1 minus 5. Simplify that, we get negative 2 plus 4 minus 5. 2 minus 5 is negative 3. So f of 1 equals negative 3 is our extreme value. And since a is negative, that is a maximum.